Beneath everyday measurements and familiar journeys lies a kind of distance that refuses to behave like any other. It is not the length of a road, or the span of an ocean, or even the width of a planet. It is a distance so vast that it breaks the mental tools evolved for understanding space at all. This distance is known as a light year, and despite its calm, technical name, it represents one of the most extreme ideas ever used in science. For most of human history, distance meant effort. It meant days of walking, weeks of sailing, months of travel across uncertain terrain. Distance was tied to fatigue, to danger, to preparation. A faraway place was somewhere that required food, shelter, time, and endurance. Even the largest distances imagined by ancient civilizations still existed within a world that could, in principle, be crossed. The Earth was big, but it was finite. The sky felt distant, but not unreachable. Then astronomy quietly shattered that sense of scale. The discovery that stars were not lights fixed to a dome, but distant suns scattered through an enormous void, forced distance to become something abstract. These were not places anyone would ever walk to, sail to, or even fly to. They were separated by emptiness, by silence, by nothing at all. Ordinary units began to fail. Kilometers could still be written down, still calculated, but they stopped meaning anything. Numbers grew larger while understanding stayed exactly the same size. A light year emerged not as a dramatic invention, but as a practical necessity. It was a concession to reality. When distances stretch beyond all familiar reference points, measurement must attach itself to something universal, something constant, something that does not depend on engines, terrain, or biology. That constant was light. Light moves through space at a fixed speed, the same everywhere, always. It does not slow with age or accelerate with ambition. It does not care about gravity except when space itself curves. It travels, relentlessly, through the dark. A light year is simply the distance covered by that motion over the span of 1 year. No metaphor, no exaggeration, no poetry. Just motion multiplied by time. And yet, the simplicity of the definition hides its violence to intuition. A light year is not just large. It is cognitively hostile. It resists visualization. It refuses compression. Every attempt to shrink it into something manageable collapses under its own weight. The mind keeps reaching for comparisons, then abandoning them. Roads become meaningless. Planets vanish into points. Even stars lose their individuality and blur into symbols on a chart. This is not a failure of intelligence. It is a consequence of evolution. Human perception developed in a world where survival depended on nearby distances, visible threats, reachable shelter. There was no advantage in understanding trillions, no need to picture emptiness stretching for years at the speed of light. The universe did not shape the brain to comprehend itself. And yet, light years describe the universe exactly as it is. Every star visible in the night sky exists at a distance measured this way. Every galaxy lies deeper still. The light arriving now began its journey long before modern cities, long before recorded history, sometimes long before civilization itself. Distance and time merge into a single concept, inseparable and unavoidable. To understand a light year is not to become comfortable with it. Comfort never arrives. Understanding comes instead as a quiet acceptance that the universe is not scaled for human intuition. It is larger, slower, older, and more patient than anything built or imagined on Earth. What follows is not an attempt to tame that scale, but to walk alongside it. Step by step, from the distances that still feel familiar, into the ones that no longer do. From seconds to years. From neighborhoods to galaxies. From space that can almost be pictured to space that simply must be acknowledged. This is the distance that breaks the brain, not through complexity, but through magnitude. A light year does not describe travel in the way distance on Earth does. It does not imply movement from one place to another in any practical sense. It describes separation. A gulf so wide that even the fastest thing that exists requires years to cross it. Light does not hesitate, it does not slow, and it does not choose its path. Once emitted, it simply goes. And still, a year passes before it arrives. To place this in context, light crosses the space between Earth and the Moon in just over a second. That distance already feels abstract, empty, and unfamiliar. There is nothing between those two bodies except darkness and vacuum. No air, no terrain, no reference points. Just separation. Yet this is only a light second. One small unit on a ladder that climbs far beyond anything encountered in daily life. Light reaches the sun in a little over 8 minutes. That means the sun is never seen as it is in the present moment. Its light always arrives late, carrying an image from the past. Even the most familiar object in the sky is separated by delay. This delay is not noticeable, but it is real, and it marks the beginning of a pattern that extends outward without limit. Beyond the sun lie the planets, and beyond the planets lies the edge of the solar system. Even at the scale of a light hour or a light day, human technology begins to struggle. Spacecraft must act autonomously. Signals take too long. Control becomes indirect. Cause and effect drift apart. A light year multiplies this separation until it becomes absolute. At that scale, distance no longer feels like something that could be crossed with enough time or effort. It becomes something static, almost geological. Stars do not feel far away in the sense that a distant mountain feels far away. They feel removed, isolated, locked into their own regions of space, each surrounded by darkness that may never be crossed. This is why the light year is unsettling. It reveals that the universe is not dense or crowded. It is sparse, vastly sparse. Stars are islands, not neighbors. Galaxies are archipelagos separated by oceans so large that even light struggles to bridge them within the age of the universe itself. When distances are described in this way, scale changes character. Bigger no longer means more impressive. It means more disconnected, more delayed, more out of reach. The universe stops behaving like a place and starts behaving like a structure that exists independently of observation or interaction. Light years are not used because they are poetic. They are used because nothing else survives contact with reality at this scale. Ordinary units shatter under the weight of emptiness. Time itself is pulled into service as a measuring tool, not because it belongs there, but because there is nothing else large enough to hold the distance steady. And even then, the mind resists. Numbers accumulate, but understanding stalls. Trillions blur into abstraction. The imagination searches for anchors and finds none. Space offers no roads, no landmarks, no sense of progression. Only separation, measured patiently by light moving through darkness, year after year. This is the environment in which stars exist, and it is the scale at which the universe operates, regardless of how difficult it is to grasp. As distance continues to expand, something subtle happens to meaning itself. A light year is not experienced as a quantity in the way smaller distances are. It is experienced as absence, the absence of proximity, the absence of immediacy. the absence of any reasonable expectation of contact. At this scale, space stops feeling like an environment and starts feeling like a condition. Between stars, there is almost nothing. The space is not filled with light, sound, or motion. It is not a corridor waiting to be crossed. It is a vacuum so complete that even particles become rare. Atoms drift so far apart that collision becomes unlikely over vast spans of time. This emptiness is not dramatic or violent. It is quiet, persistent, and indifferent. A light year captures that indifference. It describes separation without implying effort or intention. Light does not struggle across this distance. It simply moves, unchanged, until it arrives, or until it never does. The distance remains the same regardless of how it is observed. It does not compress itself to become easier to understand. Stars separated by light years are not arranged with any sense of symmetry or order that can be grasped intuitively. They are not evenly spaced. They do not form neat grids or patterns. They drift through the galaxy, bound loosely by gravity, each following its own slow orbit around a distant center. From one star to the next, the void stretches on, vast and unmarked. This is why the nearest stars still feel unreachable. Proximity becomes relative. A star described as close exists at a distance so extreme that even the fastest objects ever built would take thousands of years to arrive. The word nearby loses its familiar meaning. It becomes a technical distinction, not a practical one. Light years also expose a deeper truth about observation. Nothing is seen as it is. Everything is seen as it was. The night sky is not a snapshot of the present moment, but a layered archive of different times arriving together. Some stars appear almost current, separated by only a few years of delay. Others shine from centuries past. Others still send light that began its journey before cities existed, before empires rose, before written language formed. At larger scales, entire galaxies appear not as they are now, but as they were when life on Earth was young or non-existent. The universe presents itself as history, rather than immediacy. Distance enforces delay, and delay transforms observation into archaeology. This connection between distance and time is not an artistic metaphor. It is a physical consequence of finite speed. Information cannot travel instantly. Every photon carries not only energy, but age. The farther it travels, the older the story it tells. Light years, therefore, do more than measure space. They measure isolation. They describe how long it takes for reality to announce itself elsewhere. They reveal that events do not echo outward instantly, but ripple slowly through the universe, sometimes never reaching distant regions at all. As distances grew larger still, this delay becomes permanent. Beyond certain horizons, space expands faster than light can cross it. Messages sent from those regions will never arrive. Light emitted there will never be seen, not because of obstruction or failure, but because the structure of the universe itself prevents the connection. At this scale, separation is not temporary. It is final. Light years mark the boundary between what can, in principle, be known and what cannot. They define the limits of contact, of influence, of shared history. They describe a universe composed not of continuous space, but of regions gradually slipping beyond reach, each sealed by distance and time. This is the environment in which galaxies evolve. They form, collide, merge, and drift apart across spans measured not in generations, but in millions and billions of years. Stars are born, burn, and die without ever being noticed beyond their local neighborhood. Entire civilizations, if they exist elsewhere, could rise and fall without their light ever reaching another thinking mind. The light year stands quietly behind all of this, an unassuming unit attached to numbers too large to feel real. It does not dramatize. It does not exaggerate. It simply reports the scale at which the universe operates, regardless of whether it fits inside the limits of human intuition. And that scale continues outward, step by step, without pause. As the scale widens further, even the idea of location begins to blur. A star's position is never fixed in the way mountains or cities feel fixed. Stars move, slowly but relentlessly, orbiting the center of the galaxy along paths that take hundreds of millions of years to complete. Over a human lifetime, this motion is invisible, but over cosmic time, it reshapes everything. Constellations dissolve. Familiar patterns stretch and warp. The sky itself is temporary. Light years reveal this motion indirectly. When light leaves a star, it records not only brightness and color, but position. By the time that light arrives somewhere else, the star has already moved on. Every point of light in the sky marks where something used to be, not where it is now. The universe is always slightly out of sync with itself. At small distances, this mismatch is negligible. A few years of delay changes nothing important. But as distances grow, the gap widens. A star hundreds of light years away may have shifted significantly since its light began traveling. A galaxy millions of light years distant may have altered its shape, merged with a neighbor, or formed billions of new stars, while its older light was still in transit. At extreme distances, even existence itself becomes uncertain. Some of the most distant galaxies observed today no longer exist in the form being seen. They may have collided, transformed, or faded long ago. What remains visible is a record, not a presence. Light years turn the universe into a layered timeline, stacked in depth rather than sequence. This is why cosmic maps feel so unlike terrestrial ones. A map of Earth shows places as they are, or close enough that the difference does not matter. A map of the universe shows eras. Each region represents a different moment, preserved by distance. Looking farther is not looking elsewhere, but looking earlier. The light year also exposes the emptiness between structures. Galaxies cluster together, bound by gravity, forming groups and filaments that stretch across hundreds of millions of light years. Yet between these structures lie voids, regions where matter thins almost to nothing. These voids are not small gaps. They are immense expanses, sometimes larger than entire clusters of galaxies. Within them, stars are rare, galaxies rarer still. In these regions, light travels for millions of years without encountering anything at all. No dust clouds, no stars, no planets. Just darkness expanding quietly as the universe grows. A light year in such a void does not pass landmarks or boundaries. It simply accumulates distance. This sparsity reshapes assumptions about how common interaction can be. Even though the universe contains staggering numbers of stars and planets, they are distributed across such enormous volumes that contact becomes unlikely. Civilizations, if they arise, would be separated not by rivalry or intent, but by geometry, by sheer scale. Light years therefore describe more than measurement. They describe constraint. They define how far cause and effect can realistically propagate, how long influence takes to spread, how isolation emerges naturally from size alone. Within a galaxy, this isolation is already profound. Stars separated by a few light years share the same galactic environment, but exist in practical solitude. Planetary systems develop independently. Events around one star rarely affect another. Supernova can influence nearby regions, but even these violent explosions fade with distance. Beyond a few dozen light-years, their impact is minimal. At the scale of galaxies, the separation becomes almost absolute. Galaxies interact through gravity, but direct contact between stars from different galaxies is extraordinarily rare, even during collisions. When galaxies merge, stars pass through vast spaces between each other without ever meeting. The universe rearranges itself not through frequent impacts, but through slow, graceful motions across enormous distances. Light years make this process legible. They provide a way to speak about change that unfolds too slowly and across too much space to ever be witnessed directly. They allow patterns to emerge where individual events remain inaccessible. As scale increases, time stretches alongside distance. Processes that feel ancient on Earth become brief moments in cosmic terms. Entire species appear and vanish during the span of a single stellar orbit around the galaxy. Civilizations rise and fall while stars barely age at all. A light year becomes not just a measure of space, but a reminder of mismatched tempos. The universe moves slowly, not because it lacks energy, but because its dimensions are immense. Change is spread thin across vast regions, diluted by distance. Light years quantify that dilution. They express how long it takes for anything to matter somewhere else. And still, the expansion continues. Space itself stretches, carrying galaxies apart, increasing separation without motion. Light years accumulate even when nothing travels. Distance grows simply because the universe grows. This is the setting in which all cosmic stories unfold. A universe defined not by closeness, but by separation. Not by immediacy, but by delay. A universe where light years are not extreme units reserved for special cases, but the natural language of scale. And beyond this point, the distances only continue to grow. As these distances grow, the idea of simultaneity quietly disappears. Events that feel connected in concept are separated in reality by years, centuries, or millennia. A star can be born, burn brightly, and die while its light is still on the way to somewhere else. By the time that light arrives, the source may be gone, its atoms already scattered into space, beginning the long process of becoming something new. Light years reveal that the universe does not share a single present moment. There is no universal now. Each region exists in its own temporal frame, stitched together only by delayed signals. The farther apart two places are, the less their present moments overlap. Eventually, the overlap vanishes entirely. This has subtle consequences for how structure forms. Gravity acts across distance, but not instantly. Changes propagate outward at finite speed. When a galaxy shifts, merges, or collapses, the effects ripple through surrounding space over immense timescales. The universe responds, but slowly, as if weighted by its own size. Stars within a galaxy share a loose connection, orbiting together through a common gravitational field. Yet even here, light years enforce separation. A planetary system evolves almost entirely alone. The formation of planets, the chemistry of atmospheres, the emergence of life, if it occurs, all unfold without awareness of neighboring stars. Each system becomes a private experiment carried out in isolation. The nearest stars are separated by several light years, but most are far more distant. In the Milky Way, the average separation between stars is roughly a few light years, yet this is an average stretched across vast regions. In dense clusters, stars may pass closer, but even then, direct encounters remain rare. Space dominates. Emptiness overwhelms matter. Light years also clarify why interstellar travel feels so unattainable. Even traveling at extraordinary speeds, Distances do not yield easily. A spacecraft crossing a single light year at a fraction of light speed would still require years of uninterrupted motion. During that time, everything else continues to move. Targets shift. Destinations change. The universe does not wait. This introduces a strange asymmetry. Technology advances rapidly on human timescales, but the universe changes slowly. Missions planned decades in advance aim at objects whose positions and states were determined by light, but left long ago. Precision becomes an exercise in prediction rather than observation. At larger scales, galaxies themselves become the units of structure. They drift through expanding space, bound into clusters and superclusters by gravity. These formations stretch across tens or hundreds of millions of light-years. Between them lie voids of staggering size, where light can travel for millions of years without encountering a single galaxy. Within these voids, distance loses all reference. There is no sense of approach or departure, just persistence. Light-years accumulate without interaction, without variation. A photon can cross such a region unchanged, bearing the same energy, the same information, from one distant structure to another. This emptiness is not accidental. It is the natural result of expansion. As the universe grows, matter clumps under gravity, leaving behind increasingly vast regions of near nothingness. Over time, these voids expand faster than the structures they separate. Light years stretch not because objects move away, but because space itself grows larger. The expansion introduces horizons. There are regions so distant that light emitted there will never reach elsewhere. Not because the light is blocked or absorbed, but because the space between source and destination expands faster than light can cross it. These regions are permanently disconnected. They exist, but they do not participate in shared history. Light years therefore describe not only what is far, but what is unreachable. They define the boundary between the observable and the unknowable. Beyond certain distances, events may occur forever unseen, their light diluted and carried away by expansion, never converging on any observer. This imposes a quiet limit on knowledge. No matter how powerful instruments become, no matter how long observation continues, there will always be regions beyond reach. The universe contains more than can ever be known, not because of lack of effort, but because of geometry. At the scale of billions of light-years, even galaxies become abstractions. Their light blends together. Individual stars disappear into collective glow. Structures stretch into filaments that trace the large-scale shape of the cosmos. Patterns emerge that are invisible at smaller scales, revealing an underlying order shaped by gravity and expansion over unimaginable spans of time. Yet even these patterns are transient. Over trillions of years, galaxies will drift apart. Star formation will slow and eventually cease. Light will become rarer. The universe will grow darker, emptier, quieter. Light years will still exist, but fewer sources will remain to traverse them. This long future is encoded into present distances. Every light year carries not just separation, but destiny. It marks how long connection can persist before expansion and entropy dominate. It measures how long structures can remain aware of each other before drifting into permanent isolation. In this sense, a light year is not just a ruler. It is a timeline. It describes how long information survives, how long influence matters, how long relationships between distant regions can exist. Beyond certain scales, even gravity loses its grip and only expansion remains. Despite this, the universe remains coherent. Laws of physics hold everywhere. atoms behave the same in distant galaxies as they do locally. Light travels the same way regardless of origin. This uniformity allows distances to be measured at all. Without it, scale would collapse into chaos. Light years depend on this consistency. They rely on the idea that motion, time, and space behave predictably across the universe. That a photon emitted billions of years ago follows the same rules as one emitted now. That constants do not drift, even as space expands. This reliability is what makes comprehension possible, even when intuition fails. The mind may not visualize trillions of kilometers, but mathematics can track them. Observation can confirm them. Theory can connect them. Understanding emerges not as comfort, but as acceptance. And with each increase in scale, the lesson repeats. The universe is not built to be close. It is built to be vast. Separation is not an anomaly. It is the default state. Light years simply name the reality that has always been there, waiting to be measured. As scale continues to unfold, even the concept of neighborhood becomes fragile. Within a few light years, stars may belong to the same galactic region, yet they do not share an environment in any practical sense. Each star exists within its own sphere of influence, surrounded by planets, dust, and faint debris, shaped almost entirely by local conditions. What happens around one star rarely matters to another. Light years enforce independence. This independence is one reason the universe can be so old and yet still active. Processes unfold in parallel, scattered across vast distances, each insulated from the others by emptiness. Stars form in one region while others fade elsewhere. Entire planetary systems evolve without interruption from the wider galaxy. Time is shared, but experience is not. At this scale, cause and effect lose immediacy. Events propagate outward slowly, diluted by distance. A powerful explosion may flood its surroundings with radiation, but that influence weakens rapidly. Beyond a few dozen light years, even the most energetic events become whispers. The universe absorbs disturbance easily because it is so large. Light years make this absorption visible. They show how scale protects stability, how vastness dampens chaos. Without such distances, the universe would be violent and unpredictable. Instead, it is calm on large scales, governed by averages and slow change. Galaxies themselves are shaped by this principle. Within them, gravity binds stars together loosely, allowing structure to persist for billions of years. Yet the separation between stars ensures that collisions are rare. Even in dense regions, stars pass one another at great distances. Space dominates over matter at every level. When galaxies interact, the same rule applies. They collide, not like solid objects, but like clouds passing through one another. Stars weave through gaps so large that direct encounters are exceptional. Gas clouds compress and ignite bursts of star formation, but individual stars remain untouched. Light years act as buffers, preserving continuity even amid upheaval. Beyond galaxies, separation grows again. Clusters of galaxies orbit shared centers of mass, bound by gravity across millions of light years. These structures persist for long spans of cosmic time, yet even here expansion competes with attraction. At sufficient distances, gravity loses. Expansion wins. Clusters drift apart, slowly dissolving the large-scale architecture of the universe. This tension between gravity and expansion is written into every light year. Each unit of distance marks where one force weakens and another gains ground. Over time, the balance shifts. What is bound today may be isolated tomorrow. Light years therefore encode history and future simultaneously. They describe where things are, how long signals take to travel, and how relationships between regions evolve. Distance becomes destiny. At smaller scales, the effects are subtle. A star a few light years away remains part of the same galactic story. At larger scales, separation becomes final. Entire regions fall beyond causal contact. Shared history ends not with a dramatic event, but with silence. This silence is not empty of meaning. It defines the limits of interaction. It frames the context in which complexity arises. Life, if it emerges, does so within small islands of connectivity, surrounded by vast expanses that neither help nor hinder directly. Evolution proceeds locally, shaped by immediate conditions, largely unaware of the broader universe. Light years thus explain both abundance and isolation. They allow countless stars and planets to exist without interference, while simultaneously preventing easy connection between them. The universe can host unimaginable variety precisely because it is so large. As understanding extends outward, intuition must adapt. Distance ceases to be something crossed and becomes something endured. It is not an obstacle waiting to be overcome, but a structural feature. No amount of ingenuity changes the fact that signals take time, that expansion creates horizons, that separation grows naturally. Even theoretical ideas that imagine shortcuts through space must contend with this reality. Concepts like warped space or tunnels between regions arise precisely because light years impose such severe constraints. They are responses to scale, attempts to negotiate with geometry itself. Whether such ideas correspond to anything physically realizable remains uncertain. What is certain is that light years are not inconveniences. They are consequences. At the level of human experience, these distances feel abstract, detached from daily life. Yet they quietly define the limits of exploration and communication. They shape what can be known directly and what must remain inferred. They explain why nearby stars remain distant, why messages take years to arrive, why the universe feels vast even when filled with matter. Light years also clarify why observation requires patience. Telescopes do not simply look outward, they look backward. Each deeper view reveals an earlier state of the universe. Observations stack in time as well as space. Patterns emerge only when enough light has arrived, when enough history has accumulated. This patience mirrors the universe itself. Nothing unfolds quickly at large scales. Change takes millions or billions of years. Structures assemble slowly. Distances expand steadily. Light years provide the rhythm by which this slow unfolding is measured. In this context, the present moment becomes a narrow slice through an immense continuum. Everything visible is slightly outdated. Everything distant is ancient. The universe presents itself not as a snapshot, but as a long exposure, layered with delay. Light years make this layering unavoidable. They ensure that no observer ever sees the universe whole or current. Each vantage point carries its own horizon, its own limit of awareness. Knowledge is always partial, shaped by distance. And yet, within those limits, understanding grows. By mapping light years, patterns emerge. Relationships between structures become clear. The large-scale shape of the universe reveals itself not through immediacy, but through accumulation. Distance, once an obstacle, becomes a tool. By measuring how long light takes to arrive, age and expansion can be inferred. By comparing brightness and redshift, motion and history can be reconstructed. Light years transform delay into data. This transformation is one of the quiet triumphs of astronomy. The same distance that prevents contact enables comprehension. The same separation that isolates also informs. Light years both limit and illuminate. As scale continues to increase, this dual role persists. The universe grows larger, older, quieter. Distances stretch further. Light years accumulate, and through them, the structure of reality becomes legible, even as it remains forever beyond reach. At extreme scales, even the idea of distance as separation begins to change character. Light years no longer describe how far apart objects are in a navigational sense. They describe how long regions of the universe have existed without interacting. Space becomes less like a stage and more like a record of isolation accumulating over time. The farther outward attention moves, the more obvious it becomes that the universe does not behave like a connected system. It behaves like a collection of loosely related domains, each governed locally, each aware of the rest only through delayed signals. Light years enforce this fragmentation gently, but absolutely. This fragmentation is not chaotic. It follows precise rules. Expansion stretches space evenly in every direction. Gravity gathers matter where it can. Light moves faithfully at its constant speed, carrying information outward until expansion thins it beyond reach. Order exists, but it is distributed. Coherence survives only within limited regions. Within these regions, complexity flourishes. Stars form, planets assemble, chemistry evolves. Light years allow these processes to unfold without interference. They create conditions where systems can persist long enough for structure to arise. Without vast separation, the universe would be turbulent, dominated by collisions and constant disruption. Instead, distance grants stability. At the same time, that same stability ensures solitude. Even if life emerges in countless places, each instance remains isolated by spans of space so large that awareness of others becomes improbable. The universe may be filled with activity, yet remain silent. Light years therefore shape not only physical structure, but expectation. They explain why signals are rare, why contact is difficult, why detection depends on patience rather than immediacy. They impose a rhythm measured in decades, centuries, and millennia, rather than moments. As observations extend deeper into space, the scale of delay grows accordingly. Light from distant galaxies arrives stretched and reddened by expansion. Its wavelength lengthened, its energy reduced. This redshift encodes distance and time together. Each measurement becomes both a location and an age. In this way, light years become inseparable from cosmic history. They allow the reconstruction of events that occurred billions of years ago. The early universe, once opaque and hot, becomes visible through faint signals that have traveled nearly the entire age of existence. Distance becomes a time machine, revealing conditions that no longer exist anywhere nearby. The earliest light observable today began its journey when the universe was young, dense, and unfamiliar. Galaxies had not yet fully formed. Stars were rare. Matter had only recently cooled enough for structure to emerge. That ancient light crosses billions of light years to arrive now, carrying information from a time unreachable by any other means. Yet even this reach has limits. Beyond a certain distance, light has not had time to arrive at all. Regions exist that are completely inaccessible to observation. They are not hidden by darkness or obstruction, but by time itself. The universe is finite in age, and light years enforce that finitude. This boundary does not mark an edge of space, but an edge of visibility. Space continues beyond it, expanding, evolving, hosting processes that will never be seen. Light years define the perimeter of shared reality, beyond which events unfold in permanent privacy. Such limits challenge instinctive assumptions about completeness. There is no vantage point from which the entire universe can be seen. No observer, no matter how advanced, can escape the constraint imposed by light travel time. Knowledge remains bounded by distance. This boundedness does not diminish the universe. It defines it. The cosmos is not meant to be surveyed all at once. It reveals itself gradually, unevenly, through delayed fragments. Light years ensure that understanding accumulates slowly, requiring synthesis rather than immediacy. Within this framework, progress in knowledge depends not on speed, but on continuity. Observations taken over decades reveal motion invisible in a single moment. Measurements repeated across generations expose change too slow to perceive otherwise. Light years demand long attention. Even nearby stars illustrate this. Proper motion, the slow drift of stars across the sky, becomes apparent only through careful comparison over years. Distances measured in light years shift subtly as stars orbit the galaxy. The sky itself is dynamic, but its motion unfolds on timescales that dwarf human lifetimes. At larger scales, galaxies exhibit similar patience. Collisions take hundreds of millions of years. Starbursts flare and fade over tens of millions. Entire spiral arms wind and unwind over spans longer than complex life has existed on Earth. Light years pace all of it. This pacing reshapes the meaning of progress. Nothing cosmic happens quickly. Even dramatic events like supernova are brief only in contrast to surrounding stillness. Their influence spreads slowly, diluted by distance. After the flash fades, the universe resumes its long, quiet drift. Light years make this drift measurable. They mark how far remnants travel, how long effects linger, how influence decays. They transform time into distance, and distance into narrative. As scale increases, certainty decreases. The farther away something lies, the more its description depends on inference rather than direct measurement. Models replace immediacy. Patterns replace particulars. Light years widen the gap between observation and interpretation. Yet within that gap, insight grows. By comparing many distant objects, regularities emerge. Laws assert themselves across enormous scales. The same physics governs atoms in distant galaxies as it does locally. Light years confirm this consistency even as they separate. This universality is striking. Despite immense separation, the cosmos behaves coherently. Stars form the same way everywhere. Light propagates identically. Expansion follows the same rules across billions of light years. Distance does not fracture physics. Light years, therefore, do not isolate regions from law, only from interaction. The universe is unified in behavior, divided in contact. It is both one system and many domains. As understanding deepens, this duality becomes central. Connection exists through shared rules rather than shared experience. The universe does not require closeness to remain orderly. It requires only consistency. And that consistency stretches across every light year that can be measured. As attention moves toward the largest scales that can still be described, distance begins to dictate not just separation, but relevance. Events matter intensely where they occur, yet that importance fades rapidly with distance. Light years filter significance. What happens nearby feels immediate and consequential. What happens far away becomes abstract, delayed, and eventually unknowable. This filtering does not depend on intention or awareness. It is built into the structure of space itself. Information travels outward at a fixed speed, thinning as it goes. The farther it spreads, the weaker it becomes. Eventually, it blends into background noise, indistinguishable from randomness. Light years measure the gradual erosion of detail. Within smaller regions, this erosion is minimal. A star's light reaches nearby space still rich with information. Its spectrum carries precise details about temperature, composition, motion. Planets forming around it are bathed in that light, shaped by its energy. The system remains coherent because distance is limited. As separation increases, coherence weakens. Details smear together. Fine structure vanishes. From far enough away, a star becomes a point, then a glow, then part of a collective haze. Individual identity dissolves into statistical presence. Light years transform particulars into populations. Galaxies experience the same transition. Up close, they contain structure: arms, clusters, clouds, individual stars. From farther away, they reduce to shapes, then to smudges, then to points of light among countless others. At extreme distances, even galaxies lose individuality and merge into background radiation. This gradual loss of resolution is not failure. It is scale asserting itself. The universe does not privilege detail everywhere. It concentrates complexity locally and smooths it globally. Light years are the mechanism of that smoothing. Because of this, the universe appears simple at its largest scales. Matter distributes evenly. Temperature variations flatten. The cosmos approaches uniformity. Yet that uniformity is built from countless isolated pockets of complexity that never fully merge. This duality is central. The universe is intricate in pieces and simple in aggregate. Light years allow both conditions to coexist. They prevent complexity from spreading uncontrollably while ensuring it can persist locally. This balance shapes the fate of everything that exists. Stars burn steadily because they are isolated. Galaxies remain stable because their components rarely collide. Chemical evolution proceeds because disturbances are infrequent. Life, if it arises, benefits from this insulation. Without vast separation, everything would interfere with everything else. Radiation would saturate space. Gravitational interactions would destabilize systems. Order would collapse into constant disruption. Light years prevent this outcome by enforcing distance. At the same time, they impose loneliness. Regions of the universe do not share experience. They do not coordinate. They do not synchronize. Each evolves along its own timeline, connected only by delayed traces of light. This isolation increases with expansion. As space stretches, distances grow even between objects that are not moving through space. Expansion adds separation without effort. Light years accumulate automatically. Over time, this expansion reshapes what is possible. Regions that once shared history drift apart. Their mutual influence weakens until it vanishes entirely. They become causally disconnected, sealed within their own expanding volumes. In such a universe, shared narratives fragment. There is no single story unfolding everywhere. Instead, there are countless local stories, each unaware of the others beyond faint echoes from the distant past. Light years encode this fragmentation. They quantify how long shared experience lasts before separation overwhelms connection. They mark the boundary between collective evolution and solitary drift. This has consequences for any form of communication. Signals sent across light years arrive late, weakened, and often irrelevant by the time they are received. Context changes. circumstances evolve, meaning decays. At extreme distances, communication becomes effectively impossible. Not because messages cannot be sent, but because responses arrive too late to matter. Interaction collapses into monologue. This is not merely a technological limitation. It is a structural one. Even perfect transmitters cannot outrun geometry. Even ideal receivers cannot recover what distance erases. Light years, therefore, redefine what interaction means. They turn dialogue into correspondence, correspondence into archaeology, archaeology into silence. This silence is not empty. It is filled with unshared histories, parallel evolutions, unseen outcomes. The universe may be rich with activity, yet quiet to any given observer. Observation itself becomes selective. Telescopes reveal what distance allows, not what exists everywhere. Each observation is conditioned by light travel time and expansion. What is seen depends on when light was emitted, not when it is observed. As instruments improve, they extend reach, but they do not remove delay. Deeper observation always means older light. Progress moves backward through time, not forward through space. This inversion is fundamental. Looking farther is looking earlier. Understanding the universe requires accepting that present knowledge is built from past signals. The universe is always slightly behind itself. Light years enforce this lag universally. No observation escapes it. No vantage point offers immediacy beyond local surroundings. At the largest scales, this lag becomes the dominant feature. Entire epochs are visible simultaneously, stacked across distance. Nearby space shows recent structure. Farther space shows earlier phases. The universe reveals itself as a timeline, laid out radially. This radial time structure is one of the most profound consequences of finite light speed. It transforms space into history, distance into chronology, geometry into memory. Light years are the units of that memory. They define how much of the past can be accessed from any location. They limit retrospection just as they limit foresight. Beyond certain distances, the past itself is hidden, not because it did not happen, but because its light has not arrived. This incompleteness is permanent. As time passes, more light arrives from farther away, but expansion ensures that new regions remain forever beyond reach. The observable universe grows, but so does the unobservable. Light years, therefore, describe a universe that is never fully available to itself. No observer, anywhere, can access the whole. Each perspective is partial, bounded, conditioned by distance. This partiality does not undermine reality. It defines it. The universe does not require total visibility to function. It operates locally, governed by laws that hold everywhere, even where they are unseen. This universality amid isolation is one of the cosmos's defining traits. Physics does not vary with distance. A light year does not alter how matter behaves. It only alters when behavior becomes known elsewhere. This distinction allows science to work. Measurements made nearby apply far away. Light carries reliable information. Distance delays, but does not distort law. Without this reliability, scale would destroy understanding. With it, distance becomes a manageable obstacle rather than an absolute barrier. Light years thus occupy a strange position. They prevent contact, yet enable comprehension. They isolate regions physically, yet unite them conceptually. They enforce limits, yet reveal structure. As scale continues to increase, these roles intensify. Distances lengthen. horizons sharpen, isolation deepens, and still patterns persist. The universe grows larger, older, quieter. Light years stretch further. Separation becomes the dominant condition. But within each isolated region, complexity continues its slow work, unfolding patiently, largely unseen beyond its local domain. And the distances between those domains continue to grow, carrying them gently apart.